Good morning, good afternoon, perhaps good evening. Thanks for joining us today. My name is Jason Larson, and I'm the content director here at the International Institute for Analytics, and I'm your host for today's session. And welcome to today's webinar, Unlocking Machine Learning Success, the BizML Approach. All right, so if you are new to the International Institute for Analytics, or IIA as we like to call it, we are a research and advisory firm co-founded by Tom Davenport and CEO Jack Phillips. IIA helps enterprises measure, define, and advance their analytics and AI strategy. Transitioning to advanced analytics and AI at the enterprise level is a really hard transition to make, and we've approached this problem with a holistic set of services to guide data and analytics leaders and their teams on their analytics maturity journey. If you're new to us, check out the video on our homepage, which explains who we are, who we serve, and why we exist. From there, I encourage you to explore our latest feature content and services section of our website, which goes into more detail on how we help our clients plan and prioritize business critical initiatives, take action on those initiatives, and see real results. One thing that we really believe is we can best help our clients by delivering a range of independent expert and practitioner perspectives. So today's discussion is a part of that effort for the data and analytics community at large, an ongoing series of webinars designed to highlight important concepts, trends, and strategies relevant to DNA leaders and their teams. Okay, before we dive into the presentation, let's go over a few housekeeping items. First, be sure to follow IIA and Rackspace on LinkedIn for series announcements on our content collaboration around accelerating AI for the enterprise. We've already done a few episodes there. They're very lively, engaging discussions with some practical insights. So check on that schedule as we move along. And for today's session, we encourage you to submit questions or comments via the chat window. We really like to have these discussions be organic and interactive, and your questions help in that effort. And we make sure to save time at the end of the session to address as many questions as possible. A recorded version of this webinar will be available and emailed out after the presentation. Okay, so that's enough of that. Without further ado, we are delighted to welcome Eric Siegel as our featured speaker today. So Eric is an old friend of IIA's, and he's the founder of the long-running Machine Learning Week conference series, a frequent keynote speaker and best-selling author whose most recent book, The AI Playbook, is hot off the press. So first off, congrats on the new book, Eric. It's very exciting. I'm sure you'll talk about it a little bit here as we get into the discussion. Today's session is based on material in the AI Playbook, which introduces the BizML framework, a practical approach to ML deployment, and most importantly, which really excites us at IIA, is aligning data consumers and producers. So Eric will discuss how to bridge the gap between the data and analytics team and business stakeholders, and he's going to share some real-world case studies showcasing the do's and don'ts of ML initiatives. All right, so welcome, Eric, and I'll pass the baton to you and let you take it from here.
Great, Jason. Thanks so much for having me and all the help. I'd like to thank everyone for listening, because this is my big chance to evangelize on BizML, that framework. And I am going to introduce it. It's presented in my book. But as you said, more importantly, it's that collaboration. It's that connection between the biz and tech, essentially. So that's the bigger theme. Let's jump in. In 20 seconds, here's why machine learning is important. Business needs prediction. Prediction requires machine learning, and machine learning depends on data. Putting that in reverse, we have data, we give it to machine learning, and it generates models that predict, which is why we also sometimes call these types of enterprise use cases of machine learning predictive analytics. And more recently now, it's starting to be called predictive AI to differentiate it from generative AI. In that way, we boost sales, cut costs, combat risk, prevent fraud, fortify healthcare, streamline manufacturing, conquer spam, and win elections. This is the type of use case of machine learning predictive that you turn to if you want to improve almost any existing large-scale operation, because those operations consist of decisions, and prediction is the holy grail for decisions. So as Morgan Vaughters put it in the foreword of my new book, The AI Playbook, Morgan Vaughters of Unilever, Machine learning's practical deployment represents the forefront of human progress, improving operations with science. Thanks for listening, everyone, today, and have a great rest of the week. Oh, wait, actually, there's an issue that I would like to discuss before I let you go. You know, we generate these predictive models that I depict as golden eggs in the slides. That's the number crunching. That's the rocket science part. The question is, do we use it? Does it actually get deployed? They're meant to improve all these different operations, and often they do. Unfortunately, with new machine learning projects, more often they don't. And that last mile of the project, the actual operationalization deployment, that's very often the missing part. As a result, IBM has recently reported that the average returns of AI projects are lower than the cost of capital. And in research that I helped conduct in surveying data scientists, along with Rexer Analytics for their data science survey, only 22% of data scientists say their new initiatives usually deploy, as in more than 80% of the time. So, and there's a link to that. By the way, there's a lot of links in my slides, and you'll get access to the PDF that has additional notes for many of the slides with links to the particulars. So here's the problem in my view. We have a grave unmet need. There is no established, well-known framework, process, procedure, practice, playbook for running machine learning projects end-to-end successfully through to deployment that's well known to business users, right? Not just data scientists. In fact, in general, business stakeholders aren't generally familiar even with the need for a specialized business practice for machine learning projects in particular, but there totally is one. At the same time, those business professionals, anybody involved with a machine learning project, must be get involved with the particulars. If you don't get your hands dirty, your feet will get cold. And that's what happens. The cold feet, we hesitate, it doesn't get deployed, the failure is swept under the rug. Most new machine learning enterprise projects fail to achieve deployment. What's needed? More than anything, more than better technology, is that the business stakeholders and people involved on the business side, touched by or involved with the project, must ramp up on a certain accessible, fascinating, semi-technical understanding of machine learning projects and what it's meant to do and how it integrates, so that they can collaboratively interact and be involved with the project from end to end. So that's the bigger theme, but I will go through the 6 steps that I call BizML. Now, it turns out that adopting these steps and making sure they go, unfortunately, both sides, in the sense of data scientists and their clients, the stakeholder, the tech side versus the biz side, if you want to look at it broadly that way, both kind of point the other side for reasons that will become apparent later in my slides, and say, this isn't my responsibility. And so nobody's taking it up. So I'm going to cover a little bit more the definitions of what I mean by predictive AI. And then there's the problem, which is that these projects are routinely failing to achieve deployment. And then the green parts are the solution, that semi-technical understanding, which then makes it possible to run the BizML 6-step paradigm interactively with informed business side stakeholders collaborating deeply with data scientists. That's the solution. So a couple slides about me. My first book's called Predictive Analytics, and which was a bestseller and has been adopted at hundreds of universities. The full title of the book actually offers an informal definition of machine learning or predictive analytics, those types of predictive use cases of machine learning. Predictive analytics, the power to predict who will click, buy, lie, or die. And I'll get to a more complete definition momentarily. My new book is the AI Playbook, and that presents BizML, and the 6 steps are across 6 main chapters. But again, the bigger theme here is ramp up on semi-technical understanding so you can participate end-to-end across those steps. I've been running the Machine Learning Week conference series, formerly Predictive Analytics World, since 2009. We have a new sister conference coming. This year's event is in Phoenix, the first week of June. Hope to see you there. And the sister of co-located event there is Generative AI World. I'm also the executive editor of Machine Learning Times. Go to machinelearningtimes.com. It's a news site, and we have a monthly free newsletter. And I'm the instructor of this course, Machine Learning Leadership Practice and Mastery, which basically covers the 2 books and then a bunch more semi-technical content or accessible technical content, essentially. All right, so let's define what I mean by machine learning, a practical applied definition. Let's turn to the book, a real book. This is a real book, this is me reading the book to my son a couple years ago. He's a little older now. I recommend this book for babies, but not for toddlers. I didn't like the definition. Let's turn to this applied practical definition. Machine learning is technology that learns from experience. By experience, I mean data. Data is a recording of history. It's a long list of prior events from which it's possible to learn, that is, to derive a model that then can predict the outcome or behavior for each individual unit. So customer, patient, vehicle, image, piece of equipment, something on that level of granularity. That's what differentiates it in terms of function from forecasting. And those per individual predictions directly inform the action. This is the most actionable form of analytics, because you get these outputted predictions. A higher the number, the higher expected chance the individual will click, buy, lie, or die, like in the title of my first book, commit an act of fraud, turn out to be a fraudulent transaction, whatever it is, in order to drive better decisions. And that's a necessary part of the definition, because if you don't actually deploy it, operationalize it, change in order to improve operations with those predictions, act on them, then you're not actually capturing any value. So that's absolutely necessary. Predictions, the holy grail for improving large-scale operations, because they consist of decisions. Click, buy, lie, or die. You get that output or behavior, the probability of them, and then you can automate in many cases, or at least inform the decisions to be made with each individual. So in a nutshell, the 2 technical parts are to learn from the data and then act on what's been learned. So the data comes in from the left, and this core method, a machine learning algorithm, also known as predictive modeling, does the number crunching and then produces what I show as a golden egg, the predictive model, which then in turn is used for one individual at a time based on what's known about that individual, and puts a number, usually in the form of a probability, on the outcome or behavior you're predicting for that particular project. So that prediction on the right side is a probability. That's what we really mean by prediction. We don't have clairvoyance. We can't expect our computers to, but they can put numbers on it. We can tip the odds better by putting the number, a value between 0 and 100, 0, 1, same thing. How likely is this particular outcome for this particular individual? So we can think of a predictive model as a probability calculator. And there's the rub, people, when it comes to deployment and making a concrete business action plan. We're talking about the deployment of probabilities. So there's a little disconnect, but it's totally surmountable, right? Putting a probability on the unknown. That's essentially what we mean by prediction, both literally the future, the outcome or behavior, and also if we talk about detecting or diagnosing, is this transaction fraudulent? Does this healthcare patient have this diagnosis? We still use the word prediction. We're ascertaining it. We're trying to put odds on an unknown, even though it's not literally predicting the future. We call it a predictive model. That's just the vocabulary. So here's the problem. People shy away from probability as if it's super arcane or technical. So turn to Empire Strikes Back, where our very helpful robot C-3PO, sir, the odds of successfully navigating this asteroid field are 3,228 to 1. And then our most favorite hero ever of the whole universe, Han Solo, never tell me the odds. And I'm like, thanks, George Lucas, right? Because yes, tell me the odds. Now, in another piece of pop science, maybe not quite as popular as science fiction, we have Moneyball, right, where the Oakland A's baseball team did much better than anyone expected because they actually deployed, they acted on analytics. And this movie actually romanticized that union between the beauty and the geek, right, between the stakeholder and the data. Can you guess which actor played the data scientist in this movie? However, the movie is the epitome of glossing over the math. Now, Nate Silver's very popular book, Signal and the Noise, does espouse probabilistic thinking, but we need to go further than that. And many data scientists will be disappointed to recognize that probabilistic doing in the sense of systematically acting on probabilities over a large number of decisions is not in the general vocabulary of business folks, but it should be, because that's what it means to deploy machine learning, systematically acting on probabilities. Here's another place where people can't wrap their head around probabilities. Nate Silver got kind of crucified after the 2016 presidential election, where Clinton won. Excuse me, where Trump won after, the models were saying Clinton had a better chance. Now, Nate Silver's model didn't put a 99% chance on Clinton, put a 71% chance. A 29% chance is not a long shot. If something happens 3 out of 10 times, it shouldn't be a surprise. And Nate Silver, we can't declare the death of data as some talking heads did. Nate Silver, his model was kind of unfairly crucified in that respect. We need to wrap our heads around the simple meaning of a number. The takeaway from that 71% is uncertainty, because that's closer to 50% than it is to 100. It's closer to an unsure toss-up than a sure thing, right? So let's just think a little bit, take a deep breath, talk about the numbers a little more specifically when it comes to deploying machine learning. There's 3 things, and this is the semi-technical information and level of detail that all stakeholders need to sort of ramp up on, get comfortable with, and get involved in the details of for any given machine learning project. What's predicted, how well, and what's done about it. To data scientists, that corresponds with these technical concepts, the dependent variable, the metrics, and deployment. So what's predicted and what's done about it, that defines the machine learning use case. How well is the numbers that pertain? So those are the details I'm going to get into, and then show how those lead to a 6-step practice that I call BizML for running machine learning projects so that they actually deploy. So what's predicted and what's done about it defines the use case. For example, one of the 2 main marketing use cases of machine learning is for response modeling, targeting marketing by predicting, will each individual customer buy if contacted? That's the yes/no question that the model is trained over historical data to put probabilities on, to predict. And then based on those probabilities, you decide, who should I market to? Market to those above a certain threshold, usually, those more likely than average, above some level, to actually buy. And the numbers turn out great, right? So in a nutshell, you're looking at a customer today, you're saying, hey, should I expend the $2, the cost of contact, to send this color brochure? If I do, what are the chances that there'll be a positive outcome and they'll buy my product? And if you order your customers from most likely down to least likely, and in this case, from left to right, according to the model, to buy if contacted, then the upper line is what's called a profit curve corresponding to the predictive model's potential performance. So this is where we're turning to actual business metrics, in this case, profit, not just technical metrics about how well the thing predicts. And it kind of makes sense as you go from left to right. If you were contacting customers actually in that order, then your profit would start going up more steeply, because at the beginning of the list, those are the ones the model considers most likely to buy if contacted. So they're getting a lot more bang for your marketing buck. That starts to diminish, and eventually you've exhausted all the more responsive echelons of customers, and your profit starts to go down. And you say, oh, that's because you're not getting enough response per marketing dollar. It totally makes sense. So when you see a profit curve like this, which is very rarely seen, this is one of my main, remember, what's predicted, how well, and what's done about it. The second of those 3 is how well, the metrics, the numbers, not just predictive performance, but actual KPIs, business metrics. When you see a picture like this, it tells business stakeholders, not just data scientists, of the potential value, and informs how you should use the model, how you should deploy it. For example, you could say, hey, look, I'm going to stop at 24% and maximize my profit for the next marketing campaign targeted with this model. I'm only going to market to the top 24%, most likely respond according to the model. That's the value proposition. We're targeting marketing with prediction. The stakeholder might, though, just as well say, wait a minute, let's go over to 74%. That's where I break even. I can essentially market for free to 74% of my entire list, arguably a lot better than marketing to 100% and it costing me $550,000. So that's the metrics. That's sort of the second of these 3 things. How good is it? People don't ask how good is AI, right? How do you turn it into concrete measures? stakeholders are ready to understand that no, it doesn't predict like a magic crystal ball, and that predicting better than guessing is oftentimes sufficient. And I call that the prediction effect. A little prediction goes a long way. Predicting better than guessing delivers an improvement to the bottom line for lots of operations in marketing and well beyond. But what business stakeholders don't get yet, there's this disconnect, is turning that into business metrics. How do you look, what concrete numbers do you look at to pan out, to play out that concept that predicting better than guessing is valuable and turn it into concrete numbers? That's a practice not usually done. Everyone talks about accuracy. It's just a technical metric. So let me eviscerate accuracy so we can put it to bed once and for all. It's usually impertinent and often misleading. I call this the accuracy fallacy. So here are 4 real headlines. AI can tell if you're gay. AI predicts sexuality from one photo with startling accuracy. Linguistic analysis can accurately predict psychosis. AI-powered scans can identify people at risk of a fatal heart attack almost a decade in advance. This scary AI has learned how to pick out criminals by their faces. All of these things are essentially lies. They entirely mislead casual readers, lay people, and even casual technical readers who don't dig into the details, and mislead them into believing that the model can differentiate between positive cases and negative cases and be correct about it a great majority of the time for both positive cases and negative cases. That's untrue. We don't have clairvoyant computers. They can predict better than guessing, and there are metrics to help do that. Ultimately, what matters, though, is the improvement to the bottom line KPIs for the thing. So let's talk, for example, about the first of those, which is a pretty notorious, famous example, Stanford study predicting the sexual orientation of an individual. Well, in their data, 7% were the minority case, which is gay versus straight, which means you can get 93% accuracy by just always predicting straight and literally never correctly identifying anyone in the minority category, gay, 93. Now, what their headlines blared and made it to the front cover of The Economist, for example, 91% accuracy, not as high an accuracy. And in fact, what they were actually talking about was area under the receiver operating characteristic curve, if you can believe it, which is kind of sounds like accuracy, but it totally isn't. And it definitely means it's predicting better than guessing. So for whatever I don't know, this is more of a sociological study, but if you're predicting which customer is going to cancel or buy or whatever, there is potentially value for predicting better than guessing. But let's not mislead into that kind of crystal ball level type of performance. For example, in this particular data, if you use this model in the real world, where let's say 7%, according to that data set they were using, are in the minority category of being gay, then yes, you could use the model to correctly identify 2/3 of the gay individuals. But if you did that more than half the time the model predicted gay, it would actually be a false positive. It would be wrong. And if you wanted to correctly identify more than 2/3, the false positive rate would be even higher. The problem is that it's very hard to predict something that happens a minority of the time. But for most things you're trying to predict a value, click, buy, lie, or die, it is a minority of the time. That's why it's valuable to predict. Accuracy is impertinent and misleading. This accuracy fallacy pervades. It happens over and over again across headlines. There's a million examples. You can turn to chapter 3 of my new book or the Scientific American blog article, The Accuracy Fallacy. Again, I've got links in the notes part of the PDF you'll get. What we need to do is not just stick with technical metrics that actually do include accuracy and the area under the curve I mentioned, precision and recall. This is what data science, this is the state of the world. The data scientists operate almost entirely only with technical metrics like these that tell you only they're useful. They say, hey, this thing predicts better than guessing. Good. That potentially means it's potentially valuable. But they only tell you the relative performance in comparison to a baseline like random guessing or maybe another model. They don't tell you the absolute business value. We need to also incorporate really simple, straightforward lingua franca of business metric, KPIs, profit ROI, number of dollars saved for fraud detection, whatever it is, number of customers saved for retaining a targeted customer retention. We need to do this translation, and it's not happening. That is the very, now I cover that. There's a metrics chapter, chapter 3 of my book, the AI Playbook, also covered in this new Sloan Management Review article, what leaders should know about measuring AI project value. That difference between technical and business metrics and why the business metrics aren't generally done, but are absolutely necessary. That's a move we've got to make. Let's get this together. I'll also mention that I've co-founded a startup. It's very early, so I don't have much to show you, but we have almost done with a working prototype to do exactly that, to calculate the business metrics. It's called Gooder AI, like make your AI more gooder. Go to gooder.ai and send us a message if you're interested in being a beta customer. So let's turn to a specific example where I'm going to translate from a technical to a business metric, fraud detection, right? So let's define the use case. It's always what's predicted and what's done about it. What's predicted is the transaction fraudulent? And what's done about it, sometimes it's to audit fraud, but in this, for payment cards, it's to automatically on the fly decide whether to place a hold on high risk transactions that are above some threshold of being too likely to be fraudulent. So let's, it's one thing to say, hey, we can predict fraud better than guessing. Let's turn that into actual business metrics. So the problem is you're trying to find this balance between false positives and false negatives. A false flag or false positive is inconveniences the cardholder. The system says this is fraudulent and holds the transaction, but it was actually legitimate. So these are the two types of errors that either a human or a machine might make. Right? When they get it right, if it's fraud and it says fraud, or it's not fraud and it says not fraud, that's great. We don't have to worry about that. But we can't just say it's either right or wrong. We have to just differentiate between these two different kinds of errors. That's what you don't get from technical metrics, or some technical metrics. That's what you don't get from accuracy. It doesn't differentiate. Neither does area under the curve, which is probably the most popular technical metric. So you need to find this trade-off, and if you have a better model, it can find a better trade-off that's going to potentially pay off in terms of the bottom line. So for example, if you're let's say a medium-sized regional bank and you've issued 100,000 credit cards to your cardholders, if the fraud rate's 1 in 1,000 transactions and the average cost of fraud is $500, I'm not going to step through all the arithmetic. I'm just going to kind of give you a quick tour of the arithmetic and then point you if you want to spend time on it. But it's just arithmetic. That's the point here. It's not the rocket science part. It's how good the rocket science is, how well it performs, and how much business value you can get from it. So in that particular scenario, it would amount to the bank losing $50 million a year in fraud. So this is the arithmetic to say, hey, look, if I have a fraud detection model that can identify things more likely than average to be fraud, it's still going to be wrong. When it says something's fraud, it's still probably not fraud, but it's much more likely to be fraud than average. And it turns out if you act on that and you weigh the cost of those inconveniences to cardholders, which is usually much less costly than the actual loss due to fraud not getting captured, and you do the math, the savings is $16 million, right? We went from $50 million down to $34 million aggregate cost across those two kinds of errors. That's great. We saved $16 million and we fought crime. We improved the integrity of this core piece of commerce, right? Again, I'm not going to give you all the math. This is the same math. You can go here, you'll get the slides, and you can go to this spreadsheet if you want to play with the numbers. And again, they're also in my Sloan Management Review article and in the book. Okay, so my point there is, though, it's just arithmetic, people. You've got to get your data scientist to convert to business metrics. Technical metrics are too disconnected. They don't tell you, they don't inform whether you should authorize deployment and how to deploy. We've got to go to business metrics. Okay, so as I mentioned, what's predicted, how well, that's the metrics, and what's done about it. That definition of what's predicted, that's another semi-technical arena that you've got to get involved in, what's predicted for each individual in all great detail. So for example, I mentioned response modeling, predict who's going to buy in order to decide whether to contact them. Well, that second column here, who's going to buy, will the customer buy if contacted, that yes-no prediction goal, that's fine, but it's not sufficient. So this is one place where you need to get your hands dirty and get involved with semi-technical information. We got to get a lot more specific in fully defining what data scientists know as the dependent variable, the objective, what the model is actually predicting. It gives you a probability of what exactly? Well, let's get more concrete. If sent a brochure, will the customer buy within a time window? You have to define the time window of 13 business days. There has to be some finite amount of time you're going to wait to see what the outcome was. With a value of purchased at least 125 after shipping and not return the product for a refund within a time window of 45 days. All of these caveats and qualifiers that fully are business relevant, only semi-technical, it makes for a long yes/no question. In fact, it could easily be 3 times as many caveats as qualifiers. But the point is that they come from business pragmatics with regard to what you're planning to do in deployment. How you're going to act on the predictions depend entirely on what you're predicting, or conversely, exactly how you're intending to use those predictions directly informs that complete definition of the prediction goal. This is a perfect example of where business stakeholders have got to get involved in the details in the end-to-end practice of running a machine learning project. So those 3 things, what's predicted, how well, and what's done about it, correspond with the first 3 of 6 steps that I put together as BizML. So I'm going to tell you the other 3 steps in a second, but those first 3 steps correspond to those 3 concepts, just not quite in that order. The first is to establish the business goal, which is what's predicted and what's done about it. The second is to establish the prediction goal, which is the first of those 2, but get a lot more detailed. You've got to flesh it out in all its gory detail. And the third is to establish both the technical and the business metrics that are pertinent and the requirements on them before you're ready to authorize deployment. The other 3 steps are the same technical steps with any machine learning project. Any data scientist knows this. You got to prep the data, train the model over that data, and then deploy it, integrate it. Deployment is the goal. Essentially, step 6 is what you're planning with step 1. It's reverse planning. This is the end-to-end practice. You've got to monitor and refresh models after step 6. But for now, let's define a practice that's a common vernacular, that everyone's on the same page and understand that we need to work together to this end, where deployment is the goal. That's where you realize value. And that's the piece that's so often missing with enterprise machine learning projects. So that's why I work so hard to coin this buzzword. 5 letters, BizML, business practice for running machine learning projects. We need to have a brand for this concept to rally around and get first business practitioners on the same page that there does need to be a very specialized and particular business practice for running these projects. So by coining a catchy buzzword, I'm hoping that buzzword will catch on and thereby at least provide the story to the world that, hey, you need a very particular business practice. Now, this all comes down essentially to change management. Step 6 is to change operations in order to improve them. You're not going to get the value unless you actually change operations. Now, I'm not going to lecture on change management. It's a well-trodden area, except to say one thing. This is what's missing. People don't conceive of these projects as operations change management projects. It's as if it's just a technology project and the number crunching itself is intrinsically valuable. It isn't. It's not valuable until you act on it, implement it. Right now, the overwhelming focus of the world is on the core rocket science part. That's why I got into this more than 30 years ago. That's why most data scientists are got into the field. It's the coolest kind of science, learning from data to predict, ascertaining, drawing generalizations, finding patterns and formulas from historical examples that hold in general over new unseen cases. That's cool science. I love it. It's the best kind of science, but the number crunching is not enough. Now we have to act on it. We have to get it implemented, integrated. It's like we're fetishizing that. We need to move to the deployment. And that's the syndrome for all for most newcoming data scientists. They flock to the hands-on, and this is enabled by most technical books and courses. The first step is to load the data and make a model. But that data isn't going to prepare itself. And the requirements of it, including the full definition of the prediction goal, which is manifested in the data, not in the modeling part, rely entirely on these pre-production business steps, which you're just skipping over. It's a false narrative. Data's not going to prepare itself. It's a business project first. So in terms of taking on this project and the sort of leadership across the 6 steps, as I mentioned in the beginning, the two sides, the data scientists and the business professionals, are both kind of pointing at each other to say, you do it. Data scientists say, this is just a management issue. You know, my job is just technical. I'm meant to make a model. Of course, it's going to get deployed. It's potentially valuable. Why wouldn't the business deploy it? That's not my problem. It's my responsibility. Whereas the business professional is saying, oh, that sounds technical. That semi-technical content, this is why I have data scientists. I delegate all the particulars to the data scientists. So the faucet and the hose is failing to connect. Somebody's got to take it up. It's so ironic. It's like, by focusing so much on this core rocket science, it's like the world's more excited about the rocket science than the launch of the rocket. Business professionals also say, hey, I don't need to get involved in the details. For example, to drive a car, I don't need to pop the hood, which is totally true. I personally have no idea where the spark plugs are, and I've only looked under my hood once, and I was like, wow, there's a lot of parts. Now, I do know the concepts of internal combustion. It's cool and no reason not to learn it. But look, to drive a car, I'm an expert. I know friction, momentum, how a car operates, the rules of the road, and mutual expectations of drivers. To drive a machine learning project, you need analogous expertise on the business side, right? And I'm not going to get it all across to you in a webinar. It's totally accessible. It's much more understandable, fascinating, and pertinent and like relevant than high school algebra. Much easier. And doesn't, in terms of the math, only involves arithmetic when it comes down to the metrics, just very particular arithmetic. So it takes a book. So I'll just pitch that in addition to stepping through the 6 steps of BizML across 6 main chapters, along the way, the real purpose of my book is to ramp up business readers on that semi-technical understanding so that then they're equipped to participate and collaborate deeply across the project. So to wrap up, we need to reframe machine learning projects. Right now, the focus is entirely on the technical, which, you know, as it comes down to those 3 main kind of culminating technical production steps: prep the data, train the model, and deploy it. There's this whole other business side of machine learning projects that's generally being neglected. We need a standardized paradigm and understanding that such a thing exists, so that which can then be executed with deep collaboration that includes business side stakeholders who are first ramped up on semi-technical understanding. These aren't 2 different sides of a project. It's one project. It's a business project first with a technical component. We should potentially rename it. It's not a machine learning project. It's an operations improvement project that critically and necessarily uses machine learning as a core technical component. So critically, gain a semi-technical understanding, what's predicted, how well, and what's done about it, and then follow a specialized paradigm playbook framework, BizML, to get these things deployed. So how did I do on time? Oh, all right.
Yes, we got time for questions. So please, everyone, drop your questions and comments in the chat or the Q&A function, and we've got some time to address those. So going back to the change management piece, Eric, we did get a really good sort of comment and question around that, where in the attendees experience, you know, we need change management. To your point, right? Technology impediments, as they are often seen as a cost rather than an expense, taken out, or an accelerator. Things like data access and deployment costs due to infrastructure barriers or fear. So when you shared the stats earlier on deployment, is that what you see as the reasons for those low success rates, or are there other reasons? Is it really the change management? I mean, this is the big problem.
Essentially, in simple terms, yes. So, you know, I think it's all comes down to essentially a lack of planning, proper planning, full planning. Look, when a model gets handed over by a data scientist and then it doesn't get deployed, then the question is always they won't or they can't. So the can't would be a technical thing, right? A lot of times there's a deployment issue. There's infrastructure, technical challenges. You've got to get the right data pipelines. So whatever data was offered to the model during training is now going to be offered in real time during deployment. And you may need to integrate existing real-time operations, such as whether a transaction is being authorized instantaneously as potentially legitimate versus fraudulent. Those are legitimate engineering challenges. But again, if you're planning backwards and you're planning for a business change accordingly, and that's from the get-go, the whole point of the project, then if those go wrong, it was a lack of planning. So the difference between they can't and they won't doesn't quite exist. It's just like, hey, let's get all on the same page and see this as a business project and plan for this business change from the get-go. That's the point of the project. It's not a number crunching project. It's a business change project.
Okay. So this takes us to another question that just came in. So in your formulation here, right, we have got business people and data scientists saying it's the other person's problem, right? So, I mean, really, do you see this as an intentional shirking of accountability or lack of understanding, or maybe even an intentional lack of understanding? And the training that you just covered here, does that usually address that issue?
Well, where it's intentional, I don't want to accuse anyone of bad faith in general. I think
Yeah.
that mostly it's unintentional, and there's just sort of a lack of connection. There's sort of miles between the stuff that I call semi-technical. The data scientists will be like, that's high school, whatever, that's not technical. And the business professional will be like, that's super technical. So there's a sort of span, and to bridge it, both sides have to come in a bit. But it's not super technical once you actually look at the details of it. It really isn't. It's actually quite fascinating and it's exciting. This is what it means to improve business with science, right? It's interesting, and the core technology that we're attempting to leverage here is the best of science. It's so cool learning from data. Now, I think that there's places where there's incentives to keep it shrouded. So, for example, analytics software vendors trying to sort of sell a machine learning software tool that does the model training part, the core rocket science part. They want to give you the sense that they're selling a product that solves a business problem. But no, a machine learning project is a consulting gig, not a technology install. It depends on the organizational practice and collaboration, and whoever's leading, and I'm agnostic, it could be somebody with more of a technical background or more of a business background. Who should actually lead and make sure these things happen really depends on the particular project, how it emerged, and the particular organization. But what's important is that anyone involved makes sure somebody's tackling these 6 steps and bringing and engendering that collaboration across all 6 steps.
So this concept of probabilistic thinking, I think is difficult for a lot of non-technical people to really sort of wrap their minds around. And where I kind of go, it brings uncertainty to the discussion, right? This idea of probabilistic thinking, and possibly some anxiety and fear around the modeling and how to use the modeling to make business decisions. So have you seen probabilistic thinking and the teaching around it as part of corporate data literacy programs? And if so, like what are some examples there?
Not nearly as much as it should be, and that's what I'm trying to change, right? Yes, I see. So data literacy is the operative word here when I say you got to ramp up on semi-technical. It's just a book's worth of material, and hopefully a relatively entertaining light read book's worth, right? But you got to get involved in it. And to clarify, probabilistic thinking is one thing, and that's a phrase that, for example, Nate Silver used in his book, and he's talking about, hey, look, there's a certain probability that the economy is going to go up or down, or that a political election is going to go one way or another. Those are singular outcomes. Whereas when you're doing machine learning enterprise projects like this, it's about lots of predictions to directly inform. So I'm trying to say, hey, let's not just probabilistic thinking, it's probabilistic doing. You wrap your head around running, driving, informing, or potentially automating for some use cases, millions, if not, or at least hundreds of thousands of individual decisions based on individual probabilities. Now, but it's only semi-technical to get there. So again, if I have a list of customers, most likely down to least likely to buy if contacted, and I say, I'm going to draw a line right here at 30%, and the top 30% are worth spending the cost to contact. Right there, that simple idea of listing them in order and then drawing a line, that's all I mean. Because by doing that and just drawing this one line, I've made a million yes, no decisions. Those that are above the line are a yes, and those below are a no. I've made, and now in operation, I may literally do a million steps where for each prospect, I look at the number, I say, oh, that's not above the threshold. So this one's a no, this one's a yes. So, but the point is, it's only semi-technical. It's not that crazy to understand what it means to draw a line, a threshold to decide what probability is enough. And sometimes there's some other details. But the actual use of probabilities is not that technical. The rocket science is the part that learns some data to generate the probabilities. It's cool to learn, get a good sense of that. And indeed, chapter 5, corresponding to step 5 of my book, does get into that in an accessible way. It's the coolest science. But you don't have to be the number crunching, hands-on person. You don't need to be operating machine learning software to get what it means to act on probabilities. And there's no reason there's no reason not to learn that.
Okay. Okay. So do you see, let's say, maybe tiers of non-technical understanding across the enterprise, across business stakeholders? If we think
Yeah,
about a data literacy program or
yeah. So let me put it this way. I'm just talking about a two-dimensional graph. Anyone can learn. You might look like I showed you that profit curve. You might be, oh, well, I almost get it. Yeah, fine. You're not going to get it in 5 minutes, but it's probably only going to take you a few hours. If you're not looking at a two-dimensional graph where both dimensions are not technical but business relevant, in that case, how many customers am I contacting and what's the profit? Then you're not looking at anything. Any business stakeholder who's in charge of improving a large scale operation, whether it's marketing, fraud detection, credit risk management, which satellite to inspect as potentially running out of a battery, where to drill for oil. If you're not looking at some concrete arithmetically based numbers on the performance of your large scale operations, you're not doing your job. That's your job, is to improve a large scale operation. It's not rocket science, it's arithmetic. And we need to amp up the literacy to just do these basics. For data scientists, it's a no-brainer, but it's so simple to them, they're not bridging the gap because nobody's prompting them to.
Gotcha. So at IIA, we use kind of a framework around the information economy. So we have the supply side and the demand side, data consumers, data producers. And so, one thing that I kind of liked about the framework that you just walked through here is it does talk about those. It's talking about both sides and the collaboration there, that alignment piece. What more? So you talked about, for the data producers on the supply side, we need to move beyond technical metrics to business metrics. What more can be done on the data and analytics team for them to engage with the business around analytics?
Well, I think it's important for the data side, the data professional versus business professional, tech versus biz, right? And the way I like the way you talk about it, the producer of the analytics and the consumer. These are all the same concept, right? Just different words for the same concept. It's important for the tech side, the quant side, to know what they don't know. You can't make these semi-technical, pragmatic decisions that are based on business pragmatics, such as exactly which metric is pertinent, or which metrics are pertinent, and exactly how to define that prediction goal in all its detail in a vacuum. Those are not technical decisions. They're business pragmatic decisions based on how a business operation is going to be changed. So, everyone's got to work together. So, and that's both sides' responsibility to ensure that the collaboration is taking place. Or it's got to be somebody's responsibility, potentially the leader, whoever served has a leadership role in the project, is to, if they have to force these people to sit in a room together and hash through it, then so be it. I mean, the connection's got to be made.
Yeah, got it. Yeah, that's a good point. Um, so I mean, we've been kind of going through this past year of a lot of, you know, AI buzz, if you will, you know, Gen AI and LLMs and so forth. Um, I guess maybe if we turn to the future a little bit, like kind of applying this framework, what do you see as the future of, I guess, maybe ML implementation, you know, and this collaboration to actually make these projects succeed?
Well, first of all, just to be clear, you know, what I've been focusing on here and what I do focus on with BizML are the predictive applications. So let me
Mhm.
talk about that in the parallels between predictive and generative. They're kind of apples and oranges. It's not a zero-sum game. It's not a competition. But for time being, predictive, don't forget, predictive is where most of the money is. That's where most of the proven returns are. That's where by far, most of the investments still are. That may change. I mean, it is changing somewhat. Um, uh, it's older. Predictive use cases are established. They're older, but they're not old school.
Yeah.
It's still just the tip of the iceberg where we've tapped the potential. Um, I think in that arena, what's going to change is that it's going to become that much more clear and understood. I mean, look, if my buzzword BizML that I think is so cool doesn't actually catch on, something else will. I mean, something's got to give. We're, you know, th- my research and the IBM report I mentioned are only a couple of many continually emerging results saying, hey, look, we're not realizing value. These things are often routinely, not always, but often failing to deploy. We're not getting value. The executives are getting wise. It's not sustainable. We're running on fumes of hype. Something's got to give, and we got to be focused on concrete deployment focused value propositions and realizing those. So that's going to happen. It might be a painful adjustment. And I think that as it does happen, that it's going to be more about new enterprise processes and even new enterprises being built around this as a core component. Because right now, the way machine learning projects are usually conceived of, so we've got operations going, and it's a large scale operation, and then you say, okay, now how can we tweak and improve this by learning from the data that we've been accruing as a side effect of doing business? And that's not a bad thing. That's good. Because when you know, it's often one of the last remaining points of differentiation is to improve the operations with science, right? That's what we're essentially talking about. That's sort of a definition of machine learning, learning from data to predict, and prediction is how you improve operations. um, but it's kind of like you're playing catch up rather than having it as a centerpiece, because then what you're doing is you're kind of dealing, it's a little bit of a hack because you're trying to deal with the data in whatever way it happened to have been accrued, distributed across systems and databases and data tables. And then you have to try to put it into a meaningful, coherent form, which is called training data, where basically you have one row per example. Uh, and that's messy and it's always a specialized process. Whereas if the enterprise was planned from the get-go that, hey, we're going to start getting this going, but also we're definitely going to be uh, making these predictions and improving these operations and for this particular with this type of predictive model, it would just sort of be a coherent part of the plan from the get-go. So I think that's the shift that we're going to see start to make sense over the next 5 or 10 years. And I think that that's fascinating. I'd also like to mention, though, that generative AI stands to improve value realization in much the same way analogously, right? The 6 steps here are defined very specifically in terms of predictive use cases. But just the same, for generative, you do need to start and you do need to reverse plan. What's the deployment? What's the exact large scale operation? You know, somebody's writing 100 customer service letters a day. How are you going to use a large language model with a human in the loop? And how are you going to measure performance improvements? So again, focusing on concrete value is critical and is often missing. There's a lot of hype around generative AI, especially in the sense that it's potentially autonomous or human level or even approaching that. Um, as incredible as it is, genuinely, we need to also hold in our head at the same time that it's not human level capabilities in general, nor is it readily stepping in that direction.
All right. Great. Excellent. Well, I think that takes us to a nice conclusion. And thanks again. Really appreciate your time and your insights and bringing this discussion to our community. So, and thanks everyone who joined the call and your comments and questions. Really appreciated the dialogue there. We will be sharing a recording of this webinar, just as a reminder, in an email, and it will also be available on our website as well. And stay tuned on our email and social media channels for other upcoming blogs, webinars, ebooks, and other content. So have a great rest of your day and be well, everybody. Onward and upward.
Thank you, Jason. Thanks, everybody.
Cheers. Bye-bye.